कैमरा क्यों नहीं लोड हो रहा? तुम लोगों को नहीं दिख रहा ना कैमरा मेरा?
मेरा भी नहीं हो रहा, so can't do anything about it.
एक मिनट दूसरे स्ट्रीम पे, दूसरे उस पे ट्राई करके आती है रूम पे।
मेरा तो चल रहा है। यस
Who is wise?
यस
ये से दो बार है।
हाँ जी. Is it working
I
there?
have started the stream though.
Okay. Hi. We're just gonna be there with you guys.
Hello.
Hello, guys. Can you hear us?
Yes. We'll probably not know if you can
You're
hear us
audible.
because, like, yeah, there's going to be a delay. So,
Okay.
so
Yes, they can hear us, in fact.
yeah.
Should we wait for like a few more people to join or?
We can start, but I mean, I think yeah, we can wait for a few people to join. Till then, this is more of a casual session because, like, it's
Yeah.
we're here with you guys. We're gonna talk about a few like paradoxes and stuff that we like.
Ignore the room
Yeah,
behind me,
basically.
guys. This was very impromptu.
Ignore the room behind me too, even though nothing's visible.
Just made it worse. Okay. How are y'all? How are you guys? Did you go for inductions? What inductions did you go to? Did you come for Celestia inductions?
This is always going to delay, but yeah.
I hate delay. Oh,
Hey, Taylor. Hello, thank you, Costa, for
hi,
coming.
Costa.
Yeah, you see, that's amazing. That's amazing.
Yeah. Oh my God.
It's Manav. I know Manav, you're gonna call me,
Manav, you're
so.
rejected, actually.
No, I'm sorry. This is a joke, guys. This is Manav is not. Is a 30. He's not part of Celestia. This is no. We're gonna call it. So the album hasn't ended yet. You can still apply if you want to. The inductions are open for Celestia, and like yeah, R2 hasn't started, so don't worry about not getting a call. It's called. You're also not inducted. Again, this is a joke. Costa is also a part of
Costa is observations head, guys.
Oh, Pranav. Oh, I came for your inductions.
Oh,
Pranav.
hi, Pranav.
Pranav.
Anyway, we shouldn't favor people like that. All of you, hi.
It's not favoring. We just remember your inductions. It's
Where
nice.
is like all lives matter.
Yeah, Abdul. It's fine, Abdul. Someday we'll find you, Abdul. Maybe bring you back. I always be in this club. Always like to help.
She's always trying to be a sweetheart. Yeah.
Yes,
Everyone
exactly.
who got Yaki for induction, just like you all were very lucky. Okay.
Okay.
27 watching now.
29. Yeah, 27 watching now. That's amazing. So we're gonna start off, and let's start off with some simple stuff. We'll go to time paradoxes, but we're gonna talk some weird paradoxes that we found was fun.
Yeah.
What is the first paradox?
We like just disclaimer. This is like a casual chit chat. We just wanted to talk to you guys, see how much see what discussion we can have about the most interesting paradoxes. So
yeah, because most of the senior junior thing didn't happen a lot this year, and we were like, okay, so that's normally has a lot of senior interaction.
This isn't like a presentation where we're trying to educate you guys. We're all here to learn. All right, let's get started. Should we start?
We're gonna ask you questions also. Yeah, we're gonna. So this is how it's gonna happen. So we have a list of paradoxes. We'll pick some out for you. We'll explain what happens in those paradoxes, why they are paradoxes to begin with. We'll ask you how do you think you can resolve it, and then we'll tell you the answer if we have. We are not that smart, guys. I'm sorry.
I don't really have an answer, so maybe who knows? Maybe you solve it right here, right now, and we make history. Never underestimate it. All right, let's go. Should we start with Olbers?
Okay. No, let's start with laser faster than light because I think that's more fun. So
that's fun.
Okay. So I don't know if a lot of you have heard about this or know about this, but so imagine that you are standing on Earth, basically in underneath the night sky, and you have a laser in your hand. We have a laser in observations team. Like we use it to point to stars. It's pretty cool. You don't get it till you earn the spot. None of us have earned the spot. Sorry, guys. But you point the laser at one side of the moon, So there's the moon. You point the laser at one side of the moon, and you kind of sweep it out to the second side of the moon. Now, obviously, the moon is a huge object, like it's amazingly big. So now, in that moment, the dot of your laser went from one side of the moon to the other side in matter of seconds. If you actually calculate the entire speed that it took for the dot to go to the other side of the moon, that is much faster than the speed of light could ever go. So in that case, you must have heard that information cannot travel faster than the speed of light. So why do you think that happens, right?
Like, you understood the paradox, right? Like, when you flick your hand, it travels a very small angle. Your hand travels a very small distance, but that angle, as it's projected to a distance as large as the moon from the Earth, that the distance sort of grows exponentially. So within the time that it took you to flick your hand from here to here, it might have traveled distance more than light would have in that time. So if you think the moon can't do it, you might take a body that's even farther away, but at some point you'll hit a speed at which the dot travels faster than light. So how do you think that happens?
Yeah. So let's see if you have any answers. Yes. We love you too, Abdul and Shada. Thank you. These are all seniors, guys. Don't listen to them. We only like the firsties, like our batch.
Seniors, can you stop spamming the chat so much?
Yeah, but the information between the atoms can only travel as fast as the speed of light, so this isn't really possible. That shouldn't happen. Yes, exactly. So this is the paradox. As you can, if you can see my screen, if you can see my presentation, you can see that if you do point at and your dot of the laser does go faster than its, and that is not possible. So that's nice. You got it.
No,
individual outward. That's nice. Okay.
So Karthik, what you said, are you trying to say that the dot cannot travel faster than light, or are you saying that information didn't travel faster than light? Like, are you questioning the dot's ability to travel faster?
Good. So yeah, till that time, I think Om Devan gets it right. It's like a shadow. That is correct. It's like playing with the shadows. What is actually happening is that there is a stream of photons. As you can see, there's a stream of photons that go, and there is like at every point, a photon has another photon behind it. So in any case, even if the dot was stationary, those photons were reaching at which were traveling with the speed of light and reaching at the moon with the speed of light. All you have done is like stretch that kind of information out into a horizontal manner. Does not actually, like, just like shadows can kind of move faster than the speed of light. In the same way.
You have trouble understanding this in terms of like transfer of information, which is how we decide whether like the law of not being able to travel faster than light is correct. We usually talk about the transfer of information. So as far as transfer of information is concerned, this is essentially the same as pointing a beam of laser at point A and then pointing another beam of laser at point B simultaneously. So it's not like the same photon travels from A to B. It's more like one photon went to A and one photon went to B. And as far as we know, that can happen at infinite speed as well. Yeah, like you can do it simultaneously. So that wouldn't mean that you traveled at infinite speed, you know?
Yeah, you're right, Yash, that it won't work a physical rod, in the sense that if you like tried it with the rod and you tried of like kind of like somehow every atom kind of laid down on the moon as it touched the moon, in that case, yeah, it still wouldn't work, but the point we're trying to make is it will just lay down horizontally on the moon, and that's not the same as transferring information. One way you can think of it, like the speed limit of transfer of information, is that even if some people were standing at like this point, right, and they told me, okay, now send an information to B, it's telling me that send an information to B will take like speed of light to reach me, and then I'll see, yeah, they're telling me something, and then I'll move the light. So the speed of information is always conserved in that sense. It's always lesser than the speed.
Oh, yeah.
Yeah, the rod.
I just thought of a nice analogy. So like, hear me out. So if we talk about speed of information, okay, it's like somebody told me a fact and told me to like run like 100 meters and tell someone else the fact as I run across. That at that point I would have to obey the speed of light wala law, even if I was Flash. Okay, but but essentially what you're doing when you're pointing a laser at the moon is you tell me this piece of information right here, and then my twin stands at the other end and says that I traveled faster than light. My twin doesn't have that information with her, So that information essentially did not travel faster.
Okay, so that's nice. That's nice. I think you're getting how this is going to work. That's cool. This was a nice, easy to understand, like kind of easy to understand. It's still unintuitive. Though I have listened to this paradox for a long time, I still kind of don't understand how this works. Like in my head, I get it, but every time I see it, I was like, there's something weird about it. But that's nice. Cool. Okay. What do you want to go with the next? Let's.
Yash was asking, what I don't understand is that the photon is going to the moon and reflecting back, which Yash, it is still doing at the speed of light. It will take as long as light would take to travel. There's no way you can say that it traveled faster than light.
Okay. Cool. Awesome. We're gonna move on to Olbers paradox. Again, on my stream, you can see.
I don't think they can see that. Polish, can you show the screen?
He'll show it. He'll show it.
Okay.
Olbers paradox is like one of my favorite paradoxes because it's like closer to what an actual paradox should look like. And when I say that, it's actually very intuitive. Like the paradox itself is very intuitive, and the explanation is kind of fun. So, okay, right. So in the sense that I don't know if is my thing. No, okay, my WhatsApp sending a notification. That's fine. But the point is, Olbers paradox is basically this. Do you see this? The night sky. If you're thinking of the universe in a way which is homogeneous and has infinite stars and it is infinitely old, then and like not you don't need infinitely old. You just need very very old and very many stars. Kind of accurate in the sense.
Which we do have approximately.
Approximately. Then if you look at any point in the space, your eyes should meet like at a star in the sky. Like if it's homogeneous, if it's equally spaced everywhere, and if it has many stars, then at each point in the sky you should kind of see a star. So this is what night sky should look like according to the Olbers paradox, meaning that the entire night sky should be full with stars. But that's not what we see. What we see is a very small, like even after you remove all the light pollution, it doesn't have a lot of, it just has dots filled in like a dark. So, okay. So yeah, basically, okay. So saying, is my WhatsApp making any noise? I don't think so. But okay. In that case, why do you think this happens? How do you resolve this paradox? Do you have any kind of idea as to why the sky that we see today does not have that many stars? Dark matter and dark energy have joined the chat. Yes, they are always here for us.
Okay.
How on earth do you observe dark matter? Yeah, I mean that's
true. That's the whole point of dark matter. If dark matter were occluding stars, we would have known by now. And we would have figured out what dark matter was. But dark matter is so hard to detect. It's just we just know about dark matter because otherwise the calculations don't match up.
So the galaxies, the amount they rotate, it just doesn't match up. They need some kind of matter to explain all that kind of rotation. All the stars are not at the same distance from Earth, limited by the speed of light. That is interesting. That is interesting. So that is one of the explanations that there is a limit to the speed of light, meaning even if universe was infinite, at least only a small part of the universe is observable. So like in that case, that one point of the assumption of Olbers paradox kind of dies down. That's nice. New space is created every instant. After that,
the eyes can't see them is another thing. Like if the star is far enough away, it doesn't emit enough light that reaches the Earth. So
Yeah, the angle thing is nice, but even if they were like statistically, it should make sense for some stars to reach us, but they don't. Stars farther away redshift. So okay, this is interesting. It's not that stars farther away redshift. What you're seeing every time you look at the night sky, what you're seeing is the universe as it was in a time like in a very old time, right? You're looking into the past always because speed of light is constant. So you like, so speed light takes some time to reach us. That means you're looking in the past. So in the past, and this is another thing that comes up whenever you look into modern physics, it's even worse because in the past, the universe was completely like dense. It had light coming from everywhere. It was opaque. It was filled with plasma. It was filled with atoms buzzing around. So in that case, why is that not light blinding us if you're looking into past? And I think somebody already answered this, so we're just gonna explain that. Yeah, basically that there's a lot of red shifting. So I mean, this to a certain extent, it's true that the night sky is completely lit up. It's just lit up with the wrong kind of radiation. It's lit up with the cosmic microwave background radiation. It's not lit up with light. So yeah, if you use a radio telescope, it's very hard to get rid of that.
Exactly. You see light radio wala. I mean, you see that
Yeah.
radiation everywhere. Huh.
Okay.
Extra multiversal space. Oh my God.
What does a universe expand into?
Wow.
Okay. So the thing is, there are many ways to think about what universe expanding means. The thing is, the space, like first of all, what you're actually is just galaxies move far away, right? Is galaxies moving far away? But when you're talking about like the space-time metric, so the space-time metric or the just like the what space-time metric means is just it's a mathematical description of the geometry of space. In that case, the space-time metric is kind of changing, and it just it makes a mathematical sense. I have never seen a very visual thing to explain how to where is the space expanding into. It's the same way how you know it's the same way how light is not traveling in a medium. Light is a wave, but it's not traveling in a medium. But it's just a wave. It's just a disturbance. In the same way, space is expanding. It's not expanding into anything. It's just expanding out of it. It's just the space-time metric is changing. It's expanding into it. Yeah. Okay. This could be someone what the quantum realist to us.
I mean,
Yeah,
maybe
sure.
it's about dimensions, but
I mean, yeah. You're thinking whenever you think like that, yeah. I think this is a closed system. It could be. I mean, the thing is, a lot of these. So the pop sci thing, I think this is kind of why we put up this stream because the last stream, all of you were into pop sci a lot. So like, yeah, that's cool. Do you guys think universe is a closed system? I think. I mean, personally, I like to believe that universe is a closed system because I like to believe that if I go farther, I just come back into it. But you don't know. I mean, it is critical. It could be anywhere. I mean, I don't think there's a very reason to it. Okay.
let's come back to paradoxes though,
Mhm.
right?
Yeah.
So Olbers paradox, I guess we had enough discussion about that. We came up with a lot of theories. Mostly it's that light becomes fainter as it reaches the Earth. So
Yeah.
it makes sense that all the farther away stars are not visible and that space is expanding. So that dense blinding light from the beginning of the universe has dispersed by now,
Okay.
right? Let's go to, should we take up the solar neutrino? Oh wait, let's do unstoppable force versus immovable object.
Yeah.
It's kind of interesting.
Which one?
Unstoppable force versus immovable object.
Which? Okay, right. Unstoppable
Yeah.
force versus immovable object.
So the premise of this is essentially that.
So before we begin, like there are a lot of different kinds of paradoxes. The ones we have discussed before this is different. The way we saw that those have actual physical explanations. This has more of a tautological explanation, logical explanation.
Yeah.
So yeah.
So the premise of this is that there's an immovable object, that infinite amounts of force cannot move from its place. Okay, and there's an unstoppable force, essentially infinite force. It should be impossible to, you get what I mean. You cannot obstruct that force. If you try to obstruct that force, you will be removed from its way. So again, this is like a
So
pretty simple explanation, but like, what do you guys think is happening here? Which would win?
they've gotten a few things. The unstoppable force will pass through the immovable object. I mean, in that case, the immovable object is breakable. So in that case, they did move.
Yeah.
That's not an immovable object if it broke and moved.
Oh,
If
wait.
some part of it moved.
So when we say force, we mean mechanical force. Okay.
Yeah,
That's another
obviously.
premise. But because otherwise you could find like maybe a ray of neutrinos or something because neutrinos would be virtually unstoppable, and then the mountain could still be virtually immovable or something. But we're talking about mechanical force.
Wasn't this there in a brief history of time? Yeah, I think it was. It's been a
Probably.
long time since I read yeah. Yeah, it's Batman Joker, obviously. The answer is always Batman. So yeah. So can the force be like pressure force of light photons? Sure. I mean, it's still a mechanical force. Like it's still interacting. It's still momentum being transferred. Sure.
And
But
these are actually interesting answers. If you had like a transparent immovable object and you had like photons that wouldn't interact with the movable object. Okay,
nice.
Let's change the premise of the question again to like sort of sidetrack the maneuver around these very interesting implications. To say when we say an unstoppable force versus immovable object, the two entities have to interact with each other. So there is so one will have to either destroy the other to keep moving, or
I think somebody got it. Somebody mentioned that it's very similar to the omnipotent paradox, which is very good. Like that's a very
omnipotent paradox.
So the omnipotent paradox is basically that if you assume there is something like an omnipotent being, meaning they can do everything and they can just do everything. So I'll show you what the omnipotent paradox is. So they can just do everything. In that case, it just makes a lot of tautological nonsense. Like there will be a lot of like, okay, maybe you can't see this. Yeah, the omnipotent paradox, like, maybe you can't see it. But the point is that it will just have, if you don't have any limits in the in the limits of these of this omnipotent being, that make logically contradictory statements, such as creating a square circle. That is my favorite part. Like it's kind of, if the person can make the most, like the hardest the hardest tree,
like nothing is impossible for that being.
The strongest tree, can it even kill that tree, right? Something like that. So there's always that.
Yeah, I see. So would you guys like the solution, so to say, for this? It isn't a solution, it's more like nullifying the question itself.
Yeah, it's not supposed to do with reference of frames. As we said, it's just a logical paradox. So yeah, let's go with the solution. Let's move to the next one.
Wait, I'll tell them solution, right? So the premise of the question itself is faulty. In a universe where you have an unstoppable force, can you really have an immovable object? If you have an immovable object, then what does it mean for the force to be unstoppable? So
it's
that is
kind of a definitional. Yeah, it's kind of a definitional problem. Just like omnipotent paradox, it just doesn't make sense that the omnipotent being can make the strongest tree or the strongest human being, and then say, oh, maybe the human being can now defeat the omnipotent being back. There's just logically contradictory to have omnipotent beings.
Exactly. Like
so yeah.
It's not reference frame still. It's more like the premise cannot exist. The premise is faulty. So you can just say this situation is impossible, and hence we don't have to answer this question.
It's more like again, said, it's more like a logical tautology question. Like
Not just
it's just
impossible,
does
it is,
two things cannot have, like the definitions cannot coexist with each other. So yeah, it's not a very satisfying solution in physical spaces, but it's a satisfying solution in a logical basis if you think about it. So yeah, this is a different kind of paradox. Which one do you want to go with next? This was nice. I'm glad that you guys are kind of enjoying this. That's cool.
Okay.
The immovable is the unparallelable force. Yeah, exactly. That's a good way of saying Pranav. Yeah. For the unstoppable force, the immovable object is the unstoppable force. So think about that. Immovable force due to that. It's weird. It's weird. I mean, sure.
Let's talk
that
about
exams we hope. Yeah, go for it.
Boltzmann brain.
Oh, that's my favorite. Yeah.
Yeah.
That's my
Okay.
favorite.
Let's talk about Boltzmann brain, guys.
Okay.
So
okay, this one's even weirder. So we are going a bit farther from the physical.
A paradox.
Yeah, it's not technically a paradox. It's more like a thought experiment, which is so counterintuitive that it doesn't make sense.
Yeah. Not even counter. It's just mind blowing that this could happen. You know, life as we know it exists, sort of thing. So, yeah, should you explain?
Basically, the Boltzmann brain says that it's more likely for a single brain to have randomly, because of random external fluctuations, the single brain to have actually formed, and then because of electrical impulses, that brain is thinking that there is stuff around it. So what you're seeing right now, the amount of photons you're receiving, maybe you're not receiving those photons, because in the end, you just need an electrical impulse in a single brain to imagine that you are seeing something. You're listening to us. That information is just electrical impulses. So all you need is a single brain to come into existence, and then that brain to have electrical fluctuations in it to form our kind of universe.
And the really, really disturbing thing about it is that this is more likely to have happened than us actually having come into existence like this. You know, us being actual matter, and like that there being gravity and such things, there being multiple people, you know, us holding this live stream instead of you just receiving electrical signals in your brain that this live stream is happening.
Yep. So that's kind of, it always kind of screws everybody up, because now nothing. It's kind of like a simulation thing. It's kind of like, oh, is everything in the world a simulation? I mean, it could be.
The entire world is your simulation, and it isn't actually happening. And that's very likely, is what the thought is.
It's difficult to think of everything as illusion. Yeah. So this way, my brain is telling me about myself. Yep. Yeah. I mean, if I wanted to imagine something, I would have imagined me getting better grades. So, guys, thank you.
I mean, why can't... Honestly, if the Boltzmann brain was creating its own universe, why didn't it just make a better universe? I don't get it.
Yeah, I mean, that might be the solution to the problem. It just sucks. If we were making a thing, life would not suck that much.
Every year, if you were the Boltzmann brain. So that's why you're not the Boltzmann brain.
Okay, yeah, we're gonna talk about grandfather paradox and bootstrap. We're also going to talk about the Zeno paradox, which is also the Mercury. Like I think you meant rabbit versus tortoise paradox. That's also nice. Cool. So we're gonna move out from that. According to Hinduism,
the rabbit versus tortoise, is that the Achilles one? Like
the Achilles. Yeah, the Achilles. The Achilles, Zeno, all of these. Okay, let's start with that. So there's a lot. This is a weird paradox because I don't like the explanation that I get for this paradox. Achilles and the tortoise paradox. I hope this is the one you were talking about. Somebody who wrote in the chat.
Yes.
All three of Zeno. Yeah. I mean, even Zeno. The idea is simply that imagine a tortoise is in front of you and it's moving very small speed. And imagine there's Achilles who's trying to catch the tortoise. Every time he moves, like he covers a distance, that like every time the distance between the tortoise and him is finite, meaning he has to come closer and closer and closer and closer and closer, and he'll never reach it because every time he moves, there is some kind of distance between him and the tortoise. and it doesn't make sense that walking is possible again. Yeah, Vsauce. This is something I've seen Vsauce even though.
Has Vsauce left anything anything undiscussed so that we can come to you and like talk to you about it?
It's Vsauce and
Never seen of Vsauce.
Vsauce and Veritasium. Nothing.
Yeah.
But yeah, this is a fun paradox. I mean,
so if the tortoise keeps moving every time, how does Achilles ever get to it?
Okay, so there's somebody who says the solution is that the sum of infinite series can be finite. I like the solution because it's basically it that like the sum of an infinite series it still approaches a limit. So according to modern mathematics, the model that we should use is that limiting equation and say that it's equal. It makes sense, but I mean, I still don't see why it should be infinite in the certain sense. I think it's more important that we realize that at some point the distance is infinitesimal. I mean, still saying it's the same, it's just saying in a different word. So what we assumed in the middle was every time the Achilles and tortoise have a finite distance between them, which is not technically true. It has infinitesimal distance between them. So
if you consider the time period taken for each of these steps, okay, if it is uniform and Achilles just ran say 1 meter to catch the tortoise and it's less than 1 meter away, can't Achilles just like travel 1 more meter and be ahead of the tortoise and then catch the tortoise coming towards it? It's like travel just the distance that it took him, that the turtle traveled.
This is an IIT roper. Okay, let's see. The infinite surface area by dividing. Okay. Yeah, the infinite surface area by dividing cake and stacking the cake and dividing again, like always gets me. This is again. Point is at some point it's going to be infinitesimal. Like in reality, obviously we're bound by atoms and everything. But even if it was continuous, it's still infinitesimal and like the distance between them. That's true. Okay, cool. So yeah, let's move on to the next paradox. Which one should I go? Which one should we go for?
Per step is what I meant. But yeah, anyway, let's go to. I think Hilbert's Hotel is like a classic one, but they probably watched it.
From the Vsauce, yeah. Again,
we're gonna not count that as a reason to not discuss paradoxes, okay?
Let's go with some. So let's go with some.
So we were discussing the laser beam on moon thingy, right? There was a paper. There was research recently where a laser pulse was sent across like a 6 centimeter tube of ionized cesium or something, and that laser traveled approximately 300 times the speed of light. Okay, so how many times? So how do you think that happened? Like why could there be an explanation to?
So what exactly
faster than light and still obeys like Einstein's,
Okay. Explain the question again. So what's happening? This is the cesium tube, let's say. Yeah, go ahead.
There's a 6 centimeter tube. They sent one laser pulse from one end and it appears at the other end a few nanoseconds too quickly, according to which it's traveled at a speed that is approximately 300 times the speed of light. How would you guys think this could be possible within the laws of physics? I mean, laws of physics is very oversimplified, but you know what I mean.
Okay, so we're gonna read the chats. Please no, yeah, this is for fun. No, yeah, this is for fun. Don't worry about this.
Brahma is like, hell yeah. Please add it to my induction.
It's okay. Worry about these things. Okay, see, in the high science, assume the speed of light is constant multidirectionally. Oh yeah, according to you saw the new Veritasium video. That's true. It's not a multidirectionally; it's single directionally. So what's happening there? We could talk about that, but I don't know.
It's interesting. But
okay. Okay, let's explain. I think we are losing the chat a bit. So let's explain.
Yeah.
So what's happening?
Right. So the thing is that in the conditions that exist inside that tube, see, I don't understand it properly because I don't. I'm not very proficient in reading research papers yet. I'll get there. But yeah, what I understood it to mean is that this has something to do with the wavelength. So the conditions that existed inside that tube filled with cesium, it caused the pulse to change its wavelength drastically, due to which it was not like the pulse covered that distance within. It was not as simple as distance divided by time. It was, according to the article, something along the lines of the pulse disappeared at the pulse was sent from one point and reappeared at the other point, and very quickly. And it doesn't mean that it traveled at the speed of light, faster than the speed of light, is what I understood
So
the
in a
article
sense, transported. Oh, wow. I mean, the idea is just that the wavelength itself, you're assuming different things here. You're assuming that the light is not affected by moving through the tube, and that's weird.
Yeah,
It's
it is being
definitely weird.
it's not like a slinky that stretched out and reached the other one instead of like, you know, you know what I mean. I don't know. You guys go look that article up
It's
and
fine, it's
please
fine.
get back to us. Because
Yeah.
this is what I understood. Maybe you guys will be able to make something else out of it.
To be honest, this is a fun read if you want to go for it, because there's like it's always a fun to read new things. I think
It's not
so.
an article, sorry, it's a paper. Yeah.
It's actually, yeah, that's the whole point, is that you didn't think that this was going to be the reason. Like the first thinking that you go is what Sabyasachi meant. If the calculation is limited by higher caret, you're measuring the time.
Yeah.
But even that, like, right, the approximations that we have, the limit that we have, that's pretty high. Like I mean, it's pretty low, as in like the amount of time we can measure is pretty low because of because of using light and because of using a lot of. There are a lot of ways to doing it. Let's discuss the heat paradox. Okay. We'll talk. We'll talk about heat death paradox, but let's first talk about time paradox, because we did name this pretty hastily. So
yeah, it's
which
a
one?
nice name though. Like, no. Which time paradox do we have anyway? That you guys probably know the twin paradox and the grandfather one, huh?
Do you know how to resolve the twin paradox, though? So, okay, we'll explain you the twin paradox. Schrodinger ki billi. That's fine. It's not the it's not a paradox, to be honest. Even like, okay, this is something that I think you should. I think most people should think about. Schrodinger's cat wasn't technically like something to prove quantum mechanics. It's much more to prove that quantum mechanics is like kind of it's weird in the sense that
It's
classical
a proof of concept, I think.
it's a proof of concept that classical things cannot be quantumly like entangled. So the thing is, think about this. This cat sitting in a box with poison in it and everything, it's not a quantum piece. Like it's whenever somebody says the cat is dead and alive, that is not technically true. The cat is either dead or alive. It's a classical object. It takes a lot of effort to actually build a very quantum object. So in case like object, like it takes a lot of effort. This doesn't make sense to say this in classical sense, right? And people just used it as like proof of quantum. It's just an analogy to explain how quantum works. Yeah, Schrodinger cat is killed.
It's good publicity for quantum.
I mean, even before you open the box, right? Like even before you open the box, because it's a classical piece, because it technically limited by the quantum rules, it is probably dead or alive. Like it's either of them. It's not both of them.
Yeah, it's not. Yeah. It's essentially for explaining to
yeah. It's essentially explaining to about how quantum objects work. Like atoms can do this, but nope.
The quantum concept, it doesn't actually apply to the cat.
Yeah,
anyway, we were going to talk about the twin paradox, right?
I hope that the YouTube lag is not the video is not breaking. Voice is not breaking. Oh my god. Is it breaking?
Lag, stream lag. Okay. What can we do about that? Polish, can you do anything?
Let's see.
Eesh. Okay.
Okay. Okay, so it's corrected now mostly. That's fine. Let's move on to. So okay, this was just for a fun tangent to go for. We were going for what? The twin paradox. Yeah.
The twin
And
paradox.
this has a good physical answer to it. So I love this so much. Twin paradox. We're gonna first explain to you two things. We're gonna explain to you how twin paradox is a thing. Like what is twin paradox? So we're gonna explain to you some relativity, and then I'm going to talk to you about why this does not make sense. So the theory of relativity. If you have read about it, and if you take up courses in this thing, or we have a CT course for ourselves in that's hosted by Celestia. Yeah, there's a CT course. So Center of Technical Education has hosted a course which we are going to instruct. It's about theory of relativity. We're going to talk about this paradox even then. We're going to talk more in mathematical aspect. But like right now, just understand this, that people who are moving experience time slow. So if I was on Earth and I saw somebody on a rocket, I would say that that person on the rocket is moving slower than me, or their clock is moving slower than me. In meaning, the complete time is slower. It's not just their motion, but the complete clock. So in that case, imagine if a twin just like sits on a rocket, goes to a distant star and comes back. In that case, the twin was moving, so she kind of like aged very slowly. She was younger when she left, and by the time she came back, her twin brother actually got old. Right? That's what it see. By the time she got back, it's only been like 5 minutes, but for him, there's been like years has passed. So, I mean, not 5 minutes, but you get the point.
Yeah.
But relativity is also has one more thing. It means that the other person, like, it's relative to the frames of reference. So for the twin sister who traveled on the rocket, the brother was actually moving away from her. She was actually at rest, right?
Was that the entire paradox though? Just her coming back to find her brother older? Wasn't it that?
Yeah,
wasn't it that both of them think the other looks older or younger?
Yeah, exactly. No. The paradox is exactly this: that for the rocket girl, the Earth is actually moving very fast away from her and coming back to her. So in that case, the brother should be the one who would be younger, and the sister should have aged in the same direction. So the sister should be actually older than her, and that's the problem. So yeah, how do you resolve this paradox? Let's see. We have given you enough time. I guess we have found a solution for skin aging. Yeah, that's kind of true. I watched this thing first. Yeah, maybe. Yeah, travel. Like we say why Murphy died. Yeah, that's cool. Interstellar. Everybody has watched it. Everybody knows this paradox. It's a weird paradox.
But how do you explain what happened? Like, why is only one of them older and and why don't both of them look objectively?
Or I mean, for one, one of them expect the other one to be older. The other one expect the first one to be older. So there is definitely a paradox. Perhaps direction matters. No, relativity has. And even if direction mattered for speed of light, relativity still has the same laws, and that law does not care about direction.
Yeah, the time law will not care about the direction in which you traveled.
It's called the time. It's called the time dilation, and it just means that it's if you're moving with respect to anything.
Oh, if you guys have seen the Minute Physics ka video, he made like this nice mechanical contraption to explain how time dilates and distance shorten when speed increases.
See, for the girl, only 5 minutes passed. Time slowed down when they passed close to the black hole. Oh, yeah. I mean, that is Interstellar. Yeah, you're right. Yeah, I'm fine. It's not. It just does not exist. Like Subway Surgery. It's not weird that this happens. It just cannot exist because those two people, either of them has to be older than the other one. It can't happen that they both are younger, right? At the same point.
Yeah.
Chris, I feel I think I don't remember which one I actually understood this from, but There are a lot of YouTube videos for it. Time is shaped by clock.
Acceleration when she changed her direction.
Where is
That's
this?
interesting, yeah.
Sudden acceleration change the direction. That is correct. PS the pro.
Yeah.
I mean, we don't get your name, but yeah. I think there is a problem with the con. This one. And the other one, yeah, exactly. It is weird to think about this and cannot coexist. And the answer is PS the cave like the PS the pro. The sister had a sudden acceleration when she changed her direction. So this is something that you will understand when you take up relativity in a more mathematical basis, and something that we might teach you in this.
Lasers and mirrors.
Take
Okay.
it. But yeah, the idea is that when the sister went very far, point when she turned around and came, that's just something that you don't think about. Yeah, look at this. At the point here, when she turned around and came back, that's a point you don't think about. For this point to happen, for her to move at constant speed at this in this direction and then constant speed at this direction, it requires some infinite acceleration in this direction. Not infinite, okay, fine, but like some very big acceleration at this at this point. And that acceleration itself has some kind of relativistic equations related to it. So that is where everything kind of goes.
Yeah, I guess in one sense the answer about direction mattering was correct, because it was essentially that she changed direction and came back.
Yeah. I mean, it's not. Yeah, it's not that the direction made the relativity change. It's the actual change of the direction. It's the acceleration that relates to the direction that makes it. So this is the world line.
Changing,
This is the world line graph, right? And the world line graph is just showing you that your time axis was bent when you were traveling in one direction, and the moment you change direction, that instant acceleration is causing some certain amount of time to have crossed for you very fast, right? So that is very absolute.
Don't know world line, but like,
Yeah, that's fine.
But I mean, it has labels on the axis, so I guess you can understand from that.
Yeah, it's basically this is the length axis, this is the time axis, and when you move, the time axis kind of like bends. It's not perpendicular to the length axis when you move in a rocket. So that's okay, fine. You don't need to know much about this thing. All you need to understand is that once you make a sudden acceleration, you have an absolute freak. Like a sudden acceleration, at that point, the time flew faster for you. So yeah, that was cool. Okay. It's only been 48 minutes.
Yeah, we do need to leave in a bit.
Let's see.
We can take a probably.
And the chat has kind of settled.
Yeah.
Okay, let's go with grandfather's paradox, I guess. Let's go with the time paradox.
Grandfather is again like pretty. It's very discussed already. Like you guys can probably find out about it on your own.
Okay.
Should we talk about Fermi paradox?
So which one?
Pretty interesting.
Okay, cool.
All right.
So go for it. What is the Fermi?
So according to the Fermi paradox, so you know about Fermi estimations. If you know about Fermi estimations, you know that these are like some estimations that are made, very, very like wide estimations, like inaccurate estimations that are made, but that are intuitive, and it's basically to find out roughly how much of a quantity you should have for any particular thing. Right. So the Fermi paradox is essentially that according to Fermi, if X number of stars exist and a percentage of those stars has like X percentage of those stars have inhabitable planets in its orbit. I'm explaining to you roughly. I don't remember the exact terms. And if some of those, if a percentage of those planets have
environment suitable for life. Yeah.
Exactly. And only an like a very small percentage, like he's erring on the safe side, as in he's making like smaller and smaller estimates so that we can decrease the number of planets, so that he would actually make an estimate of planets that is smaller than the actual number of planets that we might see, right? And then so if a smaller percentage of those planets with the correct conditions has microbial life, and even smaller percentage of those planets has intelligent life, why hasn't intelligent life contacted us? Mostly because these numbers are astronomical.
There's also
So since these
there's
are
also the fraction
astronomical
of
numbers,
civilizations which have found transportation enough to get to us and the length of time. So
yeah.
considering all of that, aliens contacted us.
Yeah. So the thing is that the number that you get even after taking all of these fractions out of the last number, because the numbers are so astronomical, we still have a very large number of planets that should have a very large number of like species that should have contacted us by now. Intelligent life that should have contacted us by now. Where are they? What are they doing? Are they hiding from us? Do they not like us? Have we weirded them
Uh,
out?
Numbers are infinitesimally small.
Numbers are astronomically large, and the whole paradox is that the number that remains at the end of this is still very large. And according to that, we should have been like have a galactic have had a galactic federation by now. First German channel with 10 million. Okay, guys, let's not talk about Kurzgesagt.
I mean, it is a perfectly amazing thing.
What if we are the first
I love
intelligence?
that channel. Yeah.
Uh-huh.
What if we are the first intelligent species? Yeah, that's kind of like it's kind of the answer. Yeah.
Karthik
Time
is
frame
letting
compared to the
Karthik,
aliens. Yeah.
you're close. Yep.
Yeah. So yeah, basically, we don't consider them happening at the same time. We could have passed them. We could have been the earliest. All these things could have happened. I mean,
On this grand
also,
scale of the universe.
there's also the better explanation: hiding from us, or they're hiding from something bigger than us that we don't.
Which is nicer to make movies about.
Yeah, but it's not that much. Okay, cool. So that was pretty much what we were talk about. I think most people knew most of the stuff, so that's amazing. You guys have
Yeah.
a lot of the mathematics behind this. You can learn if you actually go ahead and like research more about this, because even we had to read up a lot before understanding a lot of these things, especially the ones which actually have a mathematical explanation, like the twin paradox. I mean, or there's also a solar neutrino paradox, or the laser. Yeah,
Oh
we
yeah,
didn't
I
talk.
read so much about that. We'll talk about that next time if we have another one of these. Yeah, but we're happy that you guys had a nice discussion in the comment section. That is essentially what we wanted, for you guys to engage in some, mental gymnastics while trying to figure these out. But yeah, we really enjoyed this session.
The Gabriel Horn solution. Yeah, okay, fine. We'll talk about this. Come to our club. Come and we'll tell you. Oh, extend. Sorry, we have instructions time, and like
Yeah.
it's a lot of time for us to
We're
actually.
very busy with you guys' inductions, so come
That's
to
fine.
induction.
We had
We'll talk to you
fun.
at induction.
We had a
Yeah.
lot of fun. And I'm glad that you guys enjoyed this in like to a certain extent that you want us to extend. This is amazing.
Yeah.
But yeah, okay. I can't join your club. Oh, it's because you're not in Discord. Maybe. But everybody in
Watch out for our
Discord.
content, I guess.
I watch out for content on this channel. I'm from the Planning Campus.
Follow us on Instagram, wherever,
It's okay. For the BitScope people, do come for inductions. Do tell your friends to come for inductions. We also have CTs, both CTs. We have quantum computation. We have theory of relativity. Join for that also. This is the next round. We'll tell you guys, or most probably by the next round you'll be inducted in our club, and we'll just have a nice get together. We'll talk about this kind of stuff. Most people are interested in this kind of crazy shits, so they just like it.
Yeah, we talk about this all the time. So join Celestia, I guess. But yeah, hopefully we can do this again. We won't deprive all of you Pilani people who joined. And we'll talk about other paradoxes.
For the Pilani people and the Hyderabad people and the non-Vixen people who joined.
Yeah. It's okay.
This is more for us to get to our first season, just understand how they're doing, just getting to know them. It's nice. Love, guys. Thank you. Well, thanks, Soham. Soham is also
this
senior.
Really fun.
This was very fun. Thanks for joining. See you next time. Oh, like, share, subscribe.
Oh, wait, they can't see us.
CS.
Stream
Cool.
ended, no?
Yeah.
Right.